Welcome to another week of our subject, Techno Apps. Again, I'm your teacher, Shalame W. Pareha. For this week's topic, we're going to talk about controlling servo motors using microcontroller. This topic is under Techno Gadget. For our situation, you wanted to build a burglar alarm for your house, but when you search online, it is kind of expensive. Having a background in microcontrollers and electronics, you have decided to build your very own alarm bot. This alarm will detect movements in 180 revolution and then scare the intruders with high-pitched alarm sound. So you can generate physical actions like in real world by controlling motors with microcontroller. Different types of motor suit different applications, and for this meeting, you will use a servo motor. So if you ever own a radio-controlled RC car, you can have across some of the servos. RC cars use them as a steering mechanism. So when we say servo motors, again, when we say servo motors or servo mechanism is an electrical motor that enables you to precisely control the position of the shaft. Standard servos or servos that usually found in the RC cars allows the position within 0 to 180 degrees fixed range, while the continuous rotation servos allows the rotation of the shaft to be set in various speeds. So there are different speeds with servo motors depending on the rotation of the shaft. So it is easy to connect a servo to an Arduino or any microcontroller platform since it only has 3 pins. The first one is power, which is the red one. It connects to the 5 volts pin, and then the ground or the black one connects to the ground pin, and then the pulse or the signal, which is usually white, yellow, or orange, is connected to any PMVW digital pin. These wires are always in this order and always in color-coded. The pin of servo is conveniently terminated into a socket into which you can just insert jumper wires to connect it to the breadboard and then to the Arduino. So servos are easily to control because of the Servo H library, and Servo.h allows Arduino board to control servo motors. So here on our diagram, we can see that use only PWM for the servo pulse pin. So these are the connection and the color-coded wires for our servo motor. So again, when we talk about the Servo.h library, Servo.h allows Arduino board to control the servo motors and can support up to 12 motors. So servos draw considerably power. So if you drive more than 1 or 2, you'll probably need to power them for a separate power supply or buy a servo shield. So the larger servo motor will have a separate power supply. For the programming side of our servo motor, we have the following. The first one is include open parenthesis servo.h and then closed. This is used to call or initialize the servo.h library. It is required to include it at the very beginning of your program. So do not forget this one. So if you're going to use a servo motor, so do not forget to include tag or hashtag, as we all know, include servo.h. Next, we have Servo, my servo. So this is used to create an instance of the servo library. So the microcontroller will identify the servo motors by given name. So you will need to create name for each motor. The microcontroller will identify the servo motors by given name. So later on, we will have our example for this. So the next one is my servo that attach pin. So to specify the pin number where the motors control the signal is connected. So for this one, we have an example. So for our example, in our example, my servo that attach open parenthesis 10, close parenthesis, means your servo signal pin is attached to Arduino digital pin 10. So it signifies that it is attached to digital pin 10. So that for, you can also set that the control pulse with or movement of our servo motor by using attached pin minimum or maximum in microseconds. So for example, minimal corresponds to the minimum 0-degree angle, while the maximum corresponds to the maximum angle, which is 180 degrees. So the next one is my servo that write or angle in degrees. So it writes or adds a value to move servo motor shaft to a new angle. So used to control the motor shaft accordingly. So for our example, we initialize the position of the shaft at 0 degrees. So the first for loop statement shaft goes from 0 degrees to 180 degrees, as you can see on our example. So while in our second loop for the loop statement, shaft goes to 180 degrees to its initial position or 0 degrees. So the next one is use microseconds. So use microseconds or microseconds. So if you want to control your servo motors in microseconds. So on standard servos or parameter value of 100, it is fully counterclockwise. So 2000 is fully counterclockwise or fully clockwise, and 1500 is in the midpoint. So there are other useful codes in servo.h library that you can use. So the first one is read. So it is used to read the current angle of your servo. For example, my servo that read. So that is our sample for a read program or read to read the angle of our servo. So next is attached. So it is used to check whether the servo variable is attached to a pin. So for our example, we have my servo that attached. So the next one is detached. So what is detached? Detach is used to detach the servo variable from its pin. So if we have attach, we have also detach. So again, attach is to locate or to check whether our servo variable is attached to a pin, and then when we say detach, it is used to detach the servo variable from its pin. So last but not the least, we have the ultrasonic sensors. So when we say ultrasonic sensors, these are sensors that are used sound waves to detect objects by utilizing the propagation of high-frequency sound waves. So as we talk about ultrasonic sensor, it can emit up to 40 kilohertz, which bounces off into the surface and back to the sensor. So the distance can be computed by using the amount of time it takes from the sound waves to return to the sensor. So that is all our topic for this week. Now let's proceed on answering our objective tests and performance tests. So just listen to the instructions given by the teacher. So if you have any more questions or clarifications, do not hesitate to send your email to me, my contact number, my Facebook account, and my MS Teams account. Thank you very much for listening. Always stay safe and happy learning to everyone.